Okay, welcome to the latest part of our radioactivity series. This time we're going to look at another type of radiation. We're going to look at beta radiation. Now, beta radiation is quite different from alpha. The symbol for beta is a sort of capital B with a long tail on it. And whereas alpha was 2 protons and 2 neutrons, beta is a single electron. Alright, did you see it there? A single electron. Okay, so it's negatively charged. Remember, the alpha particle was positively charged. In fact, it was +2. Beta is -1. Alright, so it's very, very much smaller than alpha, and it is a single electron. Okay, now using the notation, it's slightly more complex than before. Using the notation before, remember we had the symbol here, and then we had a number in this area that represented the number of protons, and a number in this area that represents the number of protons and neutrons. Now, this time, well, electron has got no protons and no neutrons, so the top number is actually very easy. The top number is in fact 0. Okay, so that's just as normal. No protons, no neutrons, so a 0 goes at the top. The number of protons down here in this area here is a little bit more complex, because you would say, well, there are no protons, therefore it should be 0 again. But in fact, in order to help us balance in the equations, what we put in here is -1. Alright? Now, the thing to do is just to learn that, rather than spend too much time trying to understand it, because it really doesn't make sense. It's not -1 proton. It has a charge of -1 though, and that helps us to balance the number of protons in an equation, and you'll see that later on. Since beta is an electron, it is very often, or most often, written as E0 -1. Okay, and so this is what you'll see in most of your question papers to represent beta radiation.